Using pandas is all about manipulating data, so let's take a look at how you can do that. The key data type, which you're going to have to get very familiar with when using pandas, is the pandas data frame. It basically represents a table with rows and columns, and pandas can take in data in a number of different formats to turn it into a data frame. For example, a dictionary where the keys are the column names and the values are a list of different values in that column. So that is a data frame. You can see it's got two different columns and each of them has the values which we had corresponding to that key. Or pandas can understand a list of lists as data. And this one is two different lists. That is two different records, each of them with three different values, which are the three different values in those columns. Or it could take in a list of dictionaries like that, where each dictionary represents a new record, and each of them has key value pairs corresponding to the column names and the value for that column for that record. And pandas can usually figure out the incoming format of the data and use that to turn it into a data frame. So you usually don't have to specify as long as you set it up in a way that's not ambiguous. It's really typical to call data frames df in Python scripts. So if you see df, that's probably what it refers to. If you take the length of a data frame, then it will give you the number of records that are in that data frame. But what's kind of surprising is if you iterate through a data frame, it's going to return you the column names like this. If you want to get all of the columns in your data frame, then you can use .columns. And that's an attribute, not a method. If you want to just check out what's in your data frame, then you can use .head to get the items at the top, or .tail to get those at the bottom. Pandas doesn't like getting indexes referring to rows. So if I add some more entries to my data and print the result of df.head, which is a method of that data frame, then head by default gets you the first 5 records. And tail gets you the last 5 rows. And you can also give either of those an argument, which is the number of records that you want to see. When you index a data frame, it expects you to give it column names. It thinks that you're going to ask which column you want to select out. And when I do give it a column name, it gives me all the values back in that column. But if you print the type of the result, it tells you that it's not a list, it's a pandas series. A series is much like a data frame, except where a data frame has rows and columns, it's 2D, a series is just one-dimensional. So it's just, like in this case, it's just a column. So in this case, indexing out a column of my data frame which has 2 dimensions, rows and columns, gives me a 1D series. But if you want to index a particular row of the data frame, you need to understand what an index column of a data frame is. So every data frame has an index column. That is what this is. This isn't one of the columns which are specified in my raw data. In this stuff, I've only got 2 columns, column 1 and column B. Not sure why I named it like that, but... And then here, this is an unnamed column. This is actually the index column of that data frame. So there's a value for each record, each row in my data frame. And the index is a unique value for each row that can be used to reference them and select them. By default, it's a range of as many integers as there are records in the data frame. But you can also set it to any other column too, and I won't go into that now. But the key thing is it's a unique value for each row. And if you want to select a particular row, you can index the lock attribute of a data frame with the value for that row in its index column, like this. So that there is me locating a particular record by its index. Notice that it's just a coincidence that the 0th row in this case has an index of 0. In other cases, the index might be an ID or a string or something like that. But in this case, the positional index is actually the same as the unique index. But I'll get onto more fancy indexing later. And similarly to the location, if you did actually want to index by position, say I wanted to get the 5th element, then I could do iloc. That's to locate a record by index position. So say if I was to do that, that gets me the 5th item. And Pandas actually has the ability to do all kinds of fancy indexing, like selecting ranges of data or just particular rows or columns where a condition is met, or even more complicated stuff as well. And that's worth going into in much more detail at another time. But I just want to give you an overview of data frames right now. Of course, you can add rows and columns to a data frame as well. You can add a column just by assigning it a new key. If I want to add a new record to a data frame, then I can use the append method. When I do that, I get this error. It says, can only append a dictionary if ignore index equals true. And so what that means is that I haven't given this an index. And so I need to say that I'm not going to give you an index. You should just assume the next default one, which in this case will be the next integer in that range. I run that, and then it actually tells me that that method is deprecated and will be removed from Pandas in a future version. So you should probably use pandas.concat instead. But the more important thing to notice is that when I ran that and printed the data frame at the end, that data frame didn't include what I just appended. And this is one important thing to notice about using pandas, is that a lot of the methods, like append, they aren't in place operations. That means they're not going to change the data frame in place. Instead, what they're going to do is return a new data frame. So typically, you need to either do something like this to overwrite the data frame equal to the new data frame, which was returned from the append method, which has the new record appended to it. Or for a lot of methods, you can pass in a keyword argument in place equal to true. And that'll perform the operation in place. So it directly changes that data frame instead of returning a new one. But that's not true for the append method. It doesn't have an in place equal true keyword argument, but you will see that in a lot of different pandas methods. So that's adding columns and adding rows. What about dropping rows and columns? Well, to do that, you can use the df.drop. And that can either drop a particular row by index, and I need to make sure the index I'm using is the same data type as the index in the data frame, which is an integer in this case by default, not a string. And in this case, I would have expected it to delete this row, but it hasn't. That's because, again, this operation isn't in place. So I need to assign the data frame to what's returned from the drop method, which should be the new data frame with that record removed. And there you have it. And this one, let's check, does it have the in place keyword argument? Yeah, this one does. So when I run that, doing this changes the data frame in place. After this line, the data frame is no longer equal to what it was before, but it's equal to the data frame after that row's been dropped. You can also delete whole columns too. And the way you can do that is by specifying the column name and then specifying the axis. So the axis is talking about, do I want to delete the rows or the columns? And it's going to be an integer, which is the index of the dimension you're talking about. So usually, when you have a matrix, the first index is the rows and then the columns and then further on. So if I put a 1 there and run that, that's saying I'm talking about dropping a column. Rows is axis 0, columns is axis 1. And you can see there that it's dropped that new column. These are just some of the key methods that you should understand about data frames from the very start, the essentials, but there's loads of other stuff too. If I do df dot, you can see a load of stuff pops up. So scanning through these, you can probably imagine what a lot of them do just by their name. You can see all kind of methods there for manipulating the data, visualizing it, loading it in, saving it, doing whatever else. There's so much stuff that pandas can do. So let's go through the docs to find out how I could use pandas to load in data directly from a CSV file rather than having it already in the Python file somehow. So to do that, I'd search Python pandas from CSV, something like that. And this first one is the pandas documentation. Click into that, and here's a great example of how most things in the pandas documentation looks like. So you can see all the different methods and attributes and classes on the left. And you can see each of them are grouped in sections. And in this one, the one I was just on is read CSV. So here it tells you where in pandas you can find it, just doing .read CSV. So in our case, this will be pd.readCSV because we typically import pandas as pd. And then this is how you call it. These are all of the possible arguments for the readCSV method from pandas. You can see all of them have default values except the file path or the buffer. Below that, you can see a description of the method, read a comma separate value file into a data frame, and so on. And then you can see a breakdown of what all of the parameters mean, what type they should be, and how you can use them. So here's the file path or buffer. It's any valid string. It could be a URL. It could point to something on S3, or more commonly, it could just point to a file locally. And it could also just be a file which you've already opened. And it could also be a file-like object which has a read method, such as what you might get inside a context manager with Python's built-in open method. Anyway, you can see a number of other methods too. So for example, you can specify where the header is. If part of your CSV represents the column names, you don't want that to be considered a row in your data frame. So you can just pass in the integer, probably 0, which is going to be the header for that CSV. You can specify the index column when you load it in, instead of assigning the default range to it, and a bunch more stuff. And then all the way below, you can see an example. This is a very simple example, but it still gets the point across. You call pd.readCSV on a file, which is a CSV file. So that's a quick blast of how to look at the documentation. So to go ahead and use that, I've got a file called jobs.csv. I've run that and it gives me a data frame which looks like this. It's a data frame with a number of different jobs, and each of them have these different columns. So you can see by default, it's correctly put the heading names into the heading. They aren't a row in the data frame like these are. So let's just remind ourselves how that's happened with the header keyword argument. By default, it infers this. And as described here, what that means is exactly the same as putting header equal to 0, because the very first line, index 0, represents the columns by default, usually. So you can see it's got the correct headings. One thing it hasn't got correct though is that there's for some reason these duplicate columns which look exactly the same. That's because this is probably meant to be the index column, but Pandas has created another one because I haven't told it that this one is the index column. So what I can do when I load it in is I can say index col equals, now what does that want? That either wants an integer or a string of the name of the column, which Pandas has set by default to unnamed :0. But I'm just going to say index col equals 0 because it's the first column, and we'll see if that works. And yeah, there you have it, correctly loaded in CSV. And now the index isn't duplicated. You're going to use this method all the time. So get used to looking at the documentation because there's a number of different ways you can have your data in, and you need to be able to understand how you might need to load things in differently if your data's in a different format. And another method you're going to use all the time is the inverse of this. Instead of loading it in, saving it. How do you save a data frame which you've got in Python? You can use that using the to methods of a data frame. So if I type df.to, you can see a load of different options come up. So here is a number of different options of how you can save the format of your data frame. You see, there's loads of ways that you can dump this data. Of course, what we're going to want to use is to CSV. But you could also save the same data in, HTML format, JSON format, NumPy format, Parquet format, SQL format, all of these. I'm going to put to CSV, and then you can simply say, what's the name of the CSV that you want to save it to? I run that, it says it's successful, and then in another file, perhaps sometime downstream, I could load that back in by doing pd.readCSV, and then the name of that file again. And there it is. And that's really the starting point for you to have a great understanding of how to use pandas for data manipulation in Python.